So since StreamYards is bugging out, I was going to do a completely different video about a quantum entanglement observed at macroscopic scales. However, instead, we're checking out some other stuff because some stuff just kind of aligned in my mind, so it seemed like a good idea. Here's the intro.
Though I know I should be wary, still I venture someplace scary. Ghostly haunting, I turn loose. Beetlejuice! Beetlejuice! Beetlejuice!
So apparently this is the Affinity Groupoid. I kinda heard about it before, and then I finished listening to one of Sean Carroll's recent guests. Totally an excellent YouTube channel with a lot of information. I totally love it. As well as a shout out to Professor Brian Keating. He is the Nick Fury of the physics community. Now, what the heck is all this stuff right here? Well, the Infinity Groupoid, brought to us by Zen Labs, which will be in the doobly-doo below. The Infinity Groupoid. Number 1. The idea. The notion of Infinity Groupoid is the generalized of group and groupoids to higher category theory. An infinity groupoid equivalently in infinity. What is that? Oh, it looks like is it 0 or omega? It's like 0 category. Oh, they're not saying 0 divided by 0 equals 0. I mean, that just gives you an error. It's kind of like, I don't know, maybe try to think of something like that. All I know is I think that's how I think. Now, at least for modern memetic theory. Why? Well, you just make a connection between different things. It's like, alright, how do you go from this to this? It's like, well, this causal relation here, here's an associative relation. I happen to have this particular experience with that falls within this valence category of this. And you just connect things out. And basically, as long as you can tell at least a coherent story, somebody might think you're completely crazy, but is it because they're crazy? Or, I don't know. Does it start to make sense? It seems like the reason some people lost their lives in The Expanse. I'm just saying. Miller was an excellent character. Now, apologies for spoilers. Or is it? The properties. Presentations. There are many ways to represent the Infinity 1 category, Infinity Groupoid, of all Infinity Groupoids, or at least obtain its homotopy category. Yes. What does that mean? That's gonna be other videos. I'm just gonna go over this real quick and just kind of explain some connections. Alright. A simple and very useful incarnation of the Infinity Groupoid is available using geometric definitions of higher categories in the form of simplest sets that are Kahn-complexes. The K cells of the underlying simplicial set are the K morphisms of the Infinity Groupoid. Essentially, the way I kind of at least understand that is, alright, you have a thing, you have a donut, however many different forms can that donut take? Alright, if you fill in the center of your traditional donut, is it still a donut? Well, it happens to be made of similar things, it happens to have a similar shape, it happens to be prepared in a similar way. I did actually notice that at Krispy Kreme. They all kind of go through the same process, and they get the glaze at the end, and then the sign comes on. And I think the Atkins diet may have killed Krispy Kreme. I'm just saying. To see how that worked there? Different associations that it went along. Is it right? I have no idea. I'm not a mathematician. What if it is? Time will tell. As well as maybe some scientific verification. That's all I'm saying. I am a theoretical mememicist. It sounds horrible. Hopefully nobody will ever use it. Alright. So, the Infinity 1 category and all Infinity Groupoids is presented along the lines by the Quillen structure on simple sets whose vibrant, cofibrant objects are precisely the Kahn-complexes. Now, again, without any research, because, well, this is the internet, and I could totally do it. I'll do it later. Who's vibrant, cofibrant, what are those? I don't know, those kind of sound like textures. Sounds like fiber. I don't know, is this string fiber? Are we talking string theory? Are we talking gluons? Isn't that how this is supposed to work? I hear many people saying these things. Basically, if you're connected at one end and another, I'm hearing things, it sounds like geometry, something that goes along that will end up connecting you probably at some form of a vector. Kind of like a triangle. It's like, alright, you got your sine, you got your cosine, and the tangent, I think, is the long part. So, defining a causal relationship. Alright. What's more important to you? Whether or not your buddy likes pineapple on pizza, or your friendship? These are some of the questions of our time. So, you can define that causal relationship, it might tell you a lot. So, blah blah blah, blah blah blah. I'm sure this is relation to infinity groups. These are presented by simplicial groups. Notably, Albion simplicial groups are therefore a model for Albion infinity groupoids. More precisely, H greater than or double Z modules under the Dolkan correspondence. So many folks in the physics and math community are going to be mad at me. It's alright, it's alright. I'm trying. I'm going to try to sign up for Wolfram Physics School. I have like one more day. Let's see if we do it. Alright. The way much of homological algebra is secretly the study of special structured infinity groupoids. Secretly? We all been keeping secrets on us. Now, we should share. Sharing is caring. That's all I'm saying. I remember that book. Maybe we'll get to more of that later. And then they go into all these different things, the terminology, but just look at this. What does it mean? Basically, aren't we kind of running into like the whole three-body problem here? Alright. You got all your terms, this and this. It's looking like sine, cosine, it's a multiplication. Sorry, you can go straight through. You can go this way. You can go this way. And then what happens? Okay, maybe that's not... Okay, something like this. It's like, you go here, there. You go there, there. And just once you get to this point, it's like, alright, what happens if you start going there and there? I don't know. Basically, if you're dealing with infinity, that's a lot. It can go on for a while. So, as long as you have your defined axiom, your different parameters, you should be able to explain it, right? That's the thing. Now you have a defined structure. It might go on forever, but if you had enough time and enough interest and maybe the computing power or attention, you could probably solve it. Is that a bad thing? I don't think so. Helps us to learn more about our universe. The more we learn about our universe, I'm just saying that maybe it can help us learn about ourselves. And maybe, just maybe, if we learn more about ourselves, we can learn more about the universe. I am not a physicist or a theologian, but just saying. Thank you all for watching. Peace out, everybody. Be safe. Long live the Elbow Bump Squirrel.